Hello everyone, welcome back to my channel. Today we are discussing class 12 mathematics project. The topic is find the area bounded by a parabola and an oblique line. For this, the format is first you have to write acknowledgement, next page content, next page topic, then introduction, next observation, next conclusion and bibliography. Okay. Now, this acknowledgement page and bibliography must be only one. That means you need not to put separate acknowledgement and bibliography for project 2. The only acknowledgement page will be the first page, that is before project 1, and the only bibliography page will be in the last page after project 2. When you are starting project 2, you just put one page where you just write project 2 section B, only write these two words. Next page will be content, next page will be topic, where you give heading and write this topic. Next page will be introduction. In introduction you write, in geometry we learned some formulas to calculate areas of various geometrical figures such as triangles, quadrilaterals, polygons and circles, etc., which are very useful in many real life problems. However, by these formulas of geometry, we can calculate areas of only simple figures. They are inadequate for calculating the areas enclosed by closed curves. For that, we need definite integrals. In fact, definite integrals have a wide range of applications. Next para. Give heading areas of bounded regions, colon underline. Then write, if the function small f is continuous and non-negative in the closed interval AB, a comma b within third bracket, then the area of the region below the curve y equal to fx above the x-axis and between the ordinates x equal to a and x equal to b, or the area of the region bounded by the curves y equal to fx, the x-axis and the ordinates x equal to a, x equal to b, is given by this symbol integration a to b fx dx or integration a to b y dx. Next para. It follows that if the graph of a function f is continuous in a closed interval and crosses the x-axis at finitely many points in a closed interval, then the area enclosed between the graph of the curve y equal to fx, the x-axis and the ordinates x equal to a, x equal to b, is given by integration a to b mod fx dx or integration a to b mod y dx. Why we have used mod here? Because for the previous case the function was given non-negative, but here the function value may be negative. So we know that the area is a positive quantity, it has only magnitude. Area must not be negative. That's why we have to put the mod sign. Okay. Next you write, here we want to find the area bounded by the parabola and an oblique line. Next para, make heading oblique line and write colon underline. Then write, an oblique line is a straight line that is not horizontal, that is neither horizontal nor vertical. So for example, horizontal means what? This line that is parallel to x-axis, and vertical means what? Which is parallel to y-axis. So oblique line means what? This. That means oblique line always makes angle, some angle theta with positive direction of x-axis. This is the oblique line. Okay. So after introduction, now we have to write observation. Introduction part completed. Next, write observation. Okay, you can put this diagram. You can write here oblique line. Just rough sketch. It will be very good. So now observation part, make heading observation and write the problem. Set the area bounded by y square equal to 8x and y equal to x along positive direction of x-axis. And this is the rough sketch. The parabola y square equal to 8x and the oblique line y equal to x. We know that this line makes angle 45 degree with positive direction of x-axis. So this is not neither horizontal nor vertical. So it is an oblique line. Now we want to find the shaded, we want to find the area of the bounded region. Means what? This is the shaded part. For this we have to find two point of intersections, and then if we find the area of the whole part, that is OABCO, and we find the area of the triangle OAB, then we subtract these two, we get the area of this bounded region. So next part is solution. First we write the given two equations and then put the value of y in equation number 1. Then we find the 2 point of intersections, that is the coordinates of O. Already we know origin O 0, 0, and the coordinates of B will be 8, 8. Now the required area bounded by the parabola and the oblique line is the whole area minus the area of the triangle. For the whole area, the value of y is y square equal to 8x, so y will be root over 8x, and for this triangle the value of y is x only, so we put the value and then normal simplifying we get this. The area is 32 by 3 square unit. Here we have used this formula, integration a to b x to the power n dx is x to the power n plus 1 by n plus 1, upper range b and lower range a. First we have to put the upper range minus the lower range, and in minus 1 the denominator is constant term. So by this formula we calculate this. After observation you put conclusion part in that page. See, introduction page, when you are writing introduction page, it may take 1 or 2 pages or 3 pages. In observation same, you can take 2 pages or 3 pages, but introduction, when you are starting introduction, it must be in separate page. When you are starting observation, it must be in separate page. Okay, and one more thing, this rough sketch, we have drawn this rough sketch here, but it will be very good if you put or if you draw this on the graph paper and paste in white, left white part of the observation. That is, in observation you are writing the right rule part in your copy, and in the left white part you paste the graph where you have drawn this diagram. And finally after observation you put conclusion. Here you write the answer, that is the area bounded by, or the required area bounded by the parabola y square equal to 8x and the oblique line y equal to x along positive direction of x axis is 32 by 3 square unit. Done. So now it's completed. Thank you everyone.